Hi everybody, welcome to the first installment of Miss Shivik's Rockin' with Ratios. I know you're all very excited for a new video, and you should all have this, a copy of these notes pasted into your notebook at this point in time, so that you can follow along. Sorry that the writing is a little small on the picture, but you should be able to follow along in your notes as I go along in the video. Okay? So ratio tables and tape diagrams are two ways to solve both simple and slightly more complicated ratio problems. Okay, it's a way to organize your thinking. And I know you're going to go, well, Miss Shivik, but I can solve it without using a ratio table and a tape diagram. Yes, I know that, so can I. But I can guarantee you that ratio tables and tape diagrams, the way you learn to organize your thinking in these problems, will be very beneficial to you later on down the line in courses like Algebra and Algebra 2, and even possibly Calculus, okay? Because it's a way of solving a complicated problem using a visual model, and it can really break things down and make them easier for you. So let's start with the first problem. The ratio of Isabella's money to Shane's money is 3 to 11. Isabella has $36. How much money do Shane and Isabella have together? Notice it's not how much money does Shane have if Isabella has $36. It's how much do they have together, okay? And this is important. Use diagrams to illustrate your answer. So I'm going to start with the ratio table model, okay? So we know that we've got three things going on here. We have Isabella, we have Shane, and we have the money that they have together. So we have Isabella's money, Shane's money, and the money that they have together, which is why I've put 3 rows into my ratio table, okay? The first thing you always want to do with a ratio table is label each row. So my first row is going to be Isabella. My second row is going to be Shane. But because we're also dealing with how much money they have together, for a third row, I'm going to put total, okay? Because Isabella and Shane are my 2 parts, but because we're going to be talking about how much money they have in total, I want to put a total line in here. Now, a lot of ratio tables can be solved with just 2 rows, but sometimes it's very helpful, like in a problem that involves a total, to have a third row. So it says that the ratio of Isabella's money to Shane's money is 3 to 11. So I can put that as my first equivalent, that first ratio in here. Isabella's got 3 for every 11 that Shane has, right? So Isabella to Shane is 3 to 11. Now, if Isabella had $3 and Shane had $11, that would give them a total of 14. So here's my part to part, but then each one of these can be looked at as a part to whole out of total, okay? Now, the question is, how much money does, if Isabella has $36, how much money do Shane and Isabella have together? So I'm going to put that next piece of information into my table, and I'm going to put it at the end because it's my end goal, right? So I want to know what's going to happen here and here when Isabella has $36. Now, I know you're kind of going, oh, but Ms. Shivik, I can just multiply Isabella by 12, and I can multiply Shane by 12, and I can multiply the total by 12, right? And I can just get right to my answer, and that's true. But sometimes it's not going to be always so obvious, so it might help to get to an intermediary step. So I'm going to do that for the example of this problem. I'm going to say, well, if Isabella has 3 and Shane has 11, then if I double that, then Isabella would have 6 and Shane would have 22, and together they would have 28, okay? Now, I can say, well, it's an easy jump from 6 to 36, right? I know that 6 times 6 is 36. So I'm going to have to multiply 22 by 6 as well. 20 times 6 would be 120. 6 times 2 would be 12. So that would give Shane $132 in that situation. Now I can very easily find their total, right? Which is what I'm looking for. How much do they total have together when Isabella has $36? Well, now all I have to do is add. I could multiply this by 6. I could say, well, I just have to do 28 times 6 as well. Or I can add these 2 together. Either way, I will get an answer of $168. Okay? So that's a way to use a ratio table. So here's my answer. They have $168. Now, what if I wanted to do this with a tape diagram? Let me zoom out a little bit, okay? Now, obviously I've drawn this tape diagram already, and as you watch me do a few of them, hopefully you'll get the hang of it. And just like in the ratio table, I want to label what I've got, right? So these are the two main parts of my tape diagram. I'll explain what this is up here in a minute. But I've got 1, 2, 3 blocks here and 11 blocks here. So what does this represent? This row represents Isabella, and this row represents Shane. Okay? So for every $3 Isabella has, Shane has $11. Now you could have put them right next to each other. I stacked them on top, and that's fine. If you wanted to, you could put them all right next to each other and just say, okay, this is Isabella and this is Shane. Totally all right. Okay? So what else do I know? I know that Isabella, right, in her 3 blocks has a total of $36. So that's what that little extra bit on top there is. Now, you don't necessarily have to put it there. You can say, oh, well, I know Isabella has $36, and that's 3 blocks. But I just like to put a little extra line up there to show that I know that this is the ratio, 3 to 11, and in this case, Isabella has 36. So that means that 36 needs to be split into 3 equal blocks. So that makes this 12, 12, and 12, okay? Which is true. We know Isabella has $36. Now, tape diagrams, the key to tape diagrams is because we're using the base ratio, all the blocks are the same, right? The ratio is 3 to 11. So for every $3 that Isabella has, Shane has $11. So each of these boxes is the same size because at the base ratio, they each represent $1. So once I know that each of these boxes actually holds, in this case, $12, Shane's boxes all hold $12 as well. 12, 12, 12, 12, 12, 12, 12, 12, 12, 12, 12, 12, and so on. Okay? So, now, if I want to know how much they have in total, well, I just got to count out how many 12s I have. I have 3 here. I have 11 here. That gives me 14 times 12, which, as we discovered earlier, equals $168. So that's a way to use a tape diagram. Okay, let's move on to the next one. So, in this problem, the student-to-faculty ratio at a small college is 17 to 3. The total of students and faculty is 640 total. How many faculty members are there at the college and how many students? Okay. So again, we're dealing with faculty, students, and total. So I'm going to make a ratio table that has 3 rows. And in those 3 rows, I'm going to put, okay, faculty, F, students, and total. I always want to label my ratio table. What do I know? Actually, change that. I'm going to put, because it goes in the other order, students, faculty, and total. My bad. All right, so what do we know? We know that for every 17 students, there are 3 faculty members. And if we looked at that, so if this college for some reason only had 17 students and 3 faculty members, that would give you a total of 20. And I want to know if there are 640 total students and faculty, what are these 2 things going to be? Now again, you can just skip right from 20 to 640 and figure out what do I need to multiply 20 by to get 640 and then multiply everything else by that. That's fine. Or you can do some intermediary steps, okay? So I'm going to say, okay, well, let's just double everything first. And that gets us to 6 and 34, okay? And let me double that again. That gets me to 80, 12, and 68, okay? Now, I'm like, well, now, you know, 20 to 640 was a big jump, but 80 to 640, that's not that hard. I just have to multiply by 8, right, to get from here to here. So now I can just go right and multiply both of these by 8. So this is a times 8. So everything else needs to be times 8 as well. So that would be 96. And that would be, let's see, 68 times 8. 60 times 8 would be 480. 8 times 8 would be 64. 480 plus 64 would give us 544. Yes, you can use a calculator. I'm just showing you that it can be done with mental math faster in the time than it takes to get a calculator. Okay, so now I know. How many students, how many faculty? There are 96 faculty members at the college and 544 students at the college. I've answered my question. And we should check, does that give me a total of 640? Well, 4 plus 6 is 10. Carry the 1, that will give me 5 plus 4 is 5 plus 9 is 14. Carry the 1, 640. Yes, it does. So what if I were going to do that with a tape diagram? What would that look like? A little bit more. Okay, so now let's look at what I have got in my tape diagram. I've set this one up a little bit differently than the one above. I stacked those on top of each other, and these ones I decided to show you where you can put them next to each other. Okay, so I know that the ratio of my students to faculty is 17:1. So I've got 17 boxes here that represent the students, and 3 boxes, 17:3. 17 boxes here that represent the students, and 3 boxes that represent the faculty. So I'm just going to put in this bar above, I'm going to put students, and then over here I'm going to put faculty. Okay. So what else do I know? So this is a representation. I know that I've got 17:3, and that comprises students and faculty. What do I know about all of these together? Well, all of these together, that's my bottom row here of my tape diagram, all of those together should add up to 640. So this 640 represents the whole thing, okay? So I've got 640 students, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Whoops, did I not have enough boxes? 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15. How annoying. I don't have enough boxes. Quick, add a few more boxes. We'll stick one there, and we'll stick one there. Okay, now they're not all even, but we should have 17 boxes there now. And 3 faculty boxes. So now I have, like I should, 20 boxes. Okay, so I've got 640 things that need to be divided evenly into 20 boxes. Grab your calculator. 640 divided by 20. You would find that there would be 32 in each box. So we're going to fill in each box with 32 things. 32, 32, 2, 32, 2, 32, 32, 32, 32, 32. Okay? So now, if I want to know how many students and how many faculty there are, I'm just going to go ahead and add another little row just above, or you could do it below as well. Okay? And I'm going to say, okay, well, these 3 boxes of 32 for the faculty, that represents 96 faculty members, because 3 groups of 32 is 96. Over here, I've got these 17 groups of 32. And if I did 17 times 32 on my calculator, I should end up with 544. Okay? So same thing we've done in the ratio table, just a slightly different setup. Okay? We should, okay, how many units do we have in total? Well, I know that equals 640. If I break them all up, that's 32 per unit. 17 of those goes with students, 3 of those go with the faculty. Okay, let's look at the final problem down here. So, the ratio of the number of people who own a smartphone to the number of people who own a flip phone is 4:3. Okay, this data must be really old, because who owns a flip phone anymore? If 500 more people own a smartphone than a flip phone, how many people own each type of phone? Okay, so let's look at the ratio table for this. And again, first thing we're going to do is we're going to label our ratio table. So we've got smartphones, we've got flip phones, and now instead of having total, we have something slightly different, right? It says if 500 more people own a smartphone. So I'm going to put this, instead of total, I'm going to put number more here, so that we have a representation of how many more it is in each scenario. So let's fill out what we know. Okay, we know that for every 4 people that own a smartphone, 3 people own a flip phone. So if these were the only people in the world that had smartphones and flip phones, there would be one more person that owned a smartphone than a flip phone, okay? Now, we want to know what happens when it's 500 more. So this is my goal. I want to know, what are these two things? How many people own smartphones and how many people own flip phones if 500 more people own a smartphone than a flip phone, okay? So again, quick look. Oh, well, I know how to get from 1 to 500. I can multiply by 500, which means I can multiply that by 500 and get 1,500, and that by 500 and get 2,000. Totally okay to do. Or if you want to do some intermediary steps, okay, you can fill in a few other ratios. Maybe you want to go up to 100, right? And that would give you, okay, well, 300 and 400. And then from there, you could just go, oh, well, times 5, times 5, times 5. Fine. Maybe you want something even a little easier to get to, 500, so maybe you could do 250 in there instead. Or maybe it might be a problem where it's asking you for each one of these how many people own smartphones and how many people own flip phones, right? So anyway, 1 to 250, that's a times 250. That would give us 750 there and 1,000 there. And you'll notice, right, 4 minus 3 is 1, 400 minus 300 is 100, 1,000 minus 750 is 250, okay? So to get from 250 to 500, we just have to double, right, a times 2. So we get 1,500 and 2,000. So we now have the scenario where 500 more people own smartphones than flip phones. So how many people own smartphones? 2,000. How many people own flip phones? 1,500. Okay, we've solved that problem. Now, I love the tape diagram for this one. Okay, it's really fun. Or it's really easy. Probably easier than just doing the ratio table. So here I've got my tape diagram set up, right? We always want to set up our tape diagram with the base ratio, which we know is 4 to 3. So this represents my smartphones, and this represents my flip phones. I know the boxes are the same size, okay, because they represent a person, right? Person, 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 person. We're going to assume all people are the same size, even though that's not technically true, right? They're still the same kind of unit of person. Now, we know that 500 more people own smartphones than flip phones in the scenario. And we're trying to figure out, okay, well then, how many people own smartphones and how many people own flip phones? Well, you will notice, right? How many extra boxes are there for smartphones? There's one extra box. So that one extra box represents the extra 500 people that own smartphones. So in that box, I can put 500 because I know, okay, this is one section more than that, and I know 500 more people own smartphones. If it were 2 extra sections, right, if it were 5 to 3 and it was 500 more people, I'd have to split that 500 between the 2 sections. But it's only one section, so I can put all 500 extra people in that section. Well, now I know the size of every box, right? 500, 500, 500, 500, 500, 500, 500. How many people own smartphones? 1, 2, 3, 4 groups of 500 is 2,000. Okay. How many people own flip phones? 3 boxes of 500 gives us 1,500, and we've solved the problem. So you can see these can be really, really useful, especially when problems get a little bit more complicated and aren't quite just like, oh, if there are 3 orange kitties for 2 brown kitties, how many orange kitties are there when there are 9 brown kitties, right? That's a very straightforward problem. You don't really need a ratio table or a tape diagram for. But when you get to more complicated problems that have involved totals or number of people more, ratio tables and tape diagrams can really be a useful tool. I hope you've enjoyed this presentation. Bye.